So, what we tried to do with OHM Light is basically a film and TV light. And what we want to do is to replace a traditional top light fixture with a low power LED source. Now, LED sources allow you to save a lot of energy, but what we wanted to do was to achieve real and measurable energy savings, because I think there's a lot of hype out there about LEDs. They save energy. A lot of fixtures actually use the same amount of energy as a traditional source. We also wanted to facilitate remote colour management to allow you to control the colour of the light without having to add gels to a fixture. So the requirements basically were it had to be at least as bright as the existing 6 kilowatt Mole-Richardson space light, which is the industry standard space light used in film and TV studios. It has to have a high colour rendering index so that it reads properly on camera and film, and HD digital imaging equipment as well. It needs to be an accurate emulation of tungsten source for image capture mainly. I'm emphasising the fact that this is aimed at image capture. It's not so much a live human eyesight light. It's aimed particularly at image capture. We need to hit the equivalent intensity and beam shape and spread at low input power so that you can do a one-for-one replacement of an existing space light. Additional accurate preset colour temperatures. The target illumination was at tungsten, which is 3200 Kelvin. We think it's very important to be able to add other colour temperatures without having to use any form of gel. It needs to be compatible with existing space light accessories such as a skirt, a silt, a target, the sort of things that studios already have piles and piles of. They can drop them on to modify the beam shapes. They can put black bags around them to give you a more concentrated beam. So the solution is the OHM Light, which uses 16 LED emitters using the Gecko Clear Colour technology. That gives us preset colour temperatures of tungsten and daylight, and a selection of other presets in between those that correspond to CTOs and CTB colour stops. As the software develops, we'll enable you to actually tune the colour between those presets, but at the moment it's just you set the presets. At the moment it's running at 900 watts input power at a tungsten colour temperature of 3200, and it actually gives you a brighter light than the 6000 watt original, and that's measured on the meter on the floor. The equivalent beam spread, which is very important, the actual distribution of the beam, allows you to do a one-for-one replacement. So where you have maybe 100 of these fixtures hanging in the roof, you can replace each one with an OHM light and you get the same distribution on the floor, so it's a one-for-one replacement. It's remote control using 4 DMX channels. One of them is master intensity, which allows you to adjust the intensity of the fixture, and there's no colour change as the intensity changes. So it's not like tungsten where you bring the intensity down and you get more yellow. It stays at the constant colour temperature. And then the other 3 DMX channels allow you to, at the moment, to select preset colours. You will be able to select user definable colours at some point in the future. And it's also got local control via LCD display, so it allows you to put it onto a stand of some sort and use it as a local key light, and the technician can just dial up the colour temperature and the intensity to match the look that you need. And it's a similar form factor. It's enclosed by the same circumscribing circle, so that the circular skirts and bags and silks and things you get for the Mole-Richardson light actually will fit to it. Just to talk a little bit about preset colour, accurate colour temperatures. Now these are calibrated at the factory. Each of the 16 arrays is calibrated by the manufacturer, and they provide a transfer function, if you like, of the current drive required to achieve a particular intensity at a particular wavelength. We can then take that information, program it into the firmware of the actual OHM light, so when you tell it we need 3200 Kelvin, it will adjust the current in the individual sections of the individual arrays to give us an accurate colour temperature. Now, as I say, the spectral output is managed to film and digital image capture. There's a lot of talk about colour temperatures and colour rendering indexes, and people bring meters and hold it in front and look at the colour temperature. A lot of meters simply take the two endpoints, one in the blue side, one in the red side, and assume there's a linear spectrum between them and give you a number. Now that doesn't actually tell you how well that will render colour and how well it will emulate a tungsten fixture on film. So what I've got here is two slides. The one on the left is tungsten, the one on the right is at daylight, 5600. The upper half of each of the colour chip squares is illuminated with a standard in process by movie film producers, and they look at it and they say, yeah, this is accurate colour. We can trim this out in our production. Colour rendering index is measured greater than 92 at 3200. I said earlier that you have to be a bit sceptical of some of these measurements, but this measurement was taken with a photo research spectrometer, and I have every reason to believe it's correct. Certainly, just standing in front of it and feeling what the light feels like, it does feel like it renders at 92. And it's a closed-loop control system, so knowing what the calibration needs to be, as the LEDs age, they gradually reduce the output. The electronics will sense that and ramp up the current level so that it stays calibrated over its lifetime. So just to quickly run through the cost savings, and these are actually measured, this is measured based on 11-hour days, 210 shooting days per year, which I think, is a reasonable movie production. The energy saving per fixture per year is 23 kilowatt hours, 23,000 kilowatt hours. Now that includes air conditioning, because with a tungsten source you're heating the air as well, and I've assumed that if you put 1 watt into the light, you have to use 1 watt of air conditioning to take that heat out of the studio. Now in actual fact, a lot of studios use 2.4 multiplier for this, so they say you've got to have 2 watts of air conditioning for each watt of power you put in. So this is actually a conservative estimate, but that looks like a considerable power saving. So if you actually convert that into cost, which I've used a 10p a unit, which is about what you get at business rate, that comes down to £2,000 a year per fixture. Because you're not having to re-gel it every time you want to change the colour temperature, you're not having to go and change incandescent bulbs, you're not having to employ people to climb ladders and swap the bulbs out. I've estimated you're probably saving 1,600 quid in consumables plus labour. So the total saving per year could be as high as £3,900 per fixture. So if we take the average movie studio that might have 100 of these fixtures, and they could see a saving of getting up for £400,000 a year. Now, some of that's estimate, some of that's guesstimate, but I don't see that that's particularly far out. I think that's a fairly achievable saving. And any questions? Oh, this one doesn't. This one absolutely does not strobe. There we go.
How much does it weigh, please?
It's about 30 kilograms.
And never having weighed a 6K, can we use the same stands or use something?
Well, it's actually 3 times heavier than a regular 6K. The sort of stands you generally use for a 6K would take it. But right. If your stand was just on the limit of taking a 6A, no, you could use the same stand. Okay. A medium Manfrotto does it, no problem at all.
Okay.
So you're saving £4,000 a year per fixture. How much more does this unit cost than the unit it would be replacing?
The standard Mole Richardson fixture is about $1,500. At the moment, this is still being sort of negotiated and talked about the list price, which won't be the price that people pay, but the list price will be about $10,000. So we reckon if you do the sums, you'll pay it back in 2.9 years. The other thing I didn't mention in the presentation is a lot of the driving for this in California is tax incentives for what they call green energy. I know this is a horrible bandwagon to get onto, but if they can be seen to be reducing energy consumption, they can actually get tax back, so the payback time reduces again.
Are they available in the UK at the moment?
We have 6 demonstration units at the moment. We're in production. They will be delivered at the end of the year.
Okay, and there'll be a rental item out. What do you see?
No, this is a sale item through
sale
PRG
only.
Distribution. Any other questions? Fine, thank you.